This video is going to be a review about how to draw the Lewis dot diagrams for molecules, and then we're going to go into the different shapes that you could get from the Lewis dot diagrams, but we'll do that in a separate video. This is going to be a little bit different from what you did in honors chemistry. So if you're like, oh yeah, I remember how to do this, let me just zone out. This is a little bit different because we're going to do some more complicated molecules here, so we're going to have to solve it a different way from the way that you did it in honors chemistry when you did all simple molecules. So what I want you to do for this one is to first add up the total number of valence electrons that you have to work with. So you're going to add up for each element how many you have and put them together. If you have a charge on it, like numbers 5 and 6 in these examples, notice they're polyatomic ions. If you have a charge, then you're going to take or add electrons to the total pool. So for number 5, once we add up our total valence electrons for nitrogen and oxygen, we're going to take 1 away since that molecule has a +1 charge. For CO3, once we add up our total valence electrons, we're going to add 2 more because it has a -2 charge. But let's go ahead and start with number 1 first. If you have a periodic table, you might want to pause this video and grab a periodic table that you can look at so you can easily see where I'm getting these numbers. And they're just the valence electrons for each element. So hydrogen has 1 valence electron, fluorine has 7, so our total electron pool is going to be 8. Then you want to go ahead and draw out your elements. We're going to go ahead and connect them with a single bond because we know they at least have a single bond. They might have double or triple as well. And that uses up 2 of the electrons, so we have 6 left. And what you want to do is try to get everybody to reach the octet rule if possible. So hydrogen is an exception to the rule. It only has an S, 1 S, and so the most electrons it can have is 2, and it already has 2 with that bond that it's sharing with fluorine. So hydrogen doesn't need any more, but fluorine still needs 6 more, and that's how many we have left. And so this would be the Lewis dot diagram for HF. Let's do another one. The next one is nitrogen, and nitrogen has 5 valence electrons. We have 2 atoms, and so our total is going to be 10. So let's go ahead and sketch it out. That gives us 2 electrons, so we have 8 left, and we can go ahead and try to spread them out as much as we can. So 2, 4, 6, 8, 10, and I'm out of electrons. So we only have 10, and one of the nitrogens, the one on the right, has all 8. But the one on the left only has 4, and that's not okay. So when you are short electrons, you have to make multiple bonds. Some people start to make double or triple bonds all the time. So you can't do that. You can only do that when you're short electrons. So let's go ahead and take off some of these electrons. And let's say we have 2, 4, 6, 8, 10. So I'm getting close. Oops, I did too many for that one. So 2, 4, 6, 8, 10. I'm getting closer. So now the one on the right is good. It has 4 that it's sharing. So if it has a double bond, that means 4 total electrons. And then 2 more pairs on the outside would give us 8. But the nitrogen on the left only has 6. So we're almost there. We're still short, so we're going to make 1 more bond here. So that's 2, 4, 6, 8, 10, and now each nitrogen has all 8 electrons, 6 that they're sharing, plus 2 more that belong only to them. That's called a lone pair, by the way. Those electrons there are lone pairs. I didn't circle it very well. Lone pairs. All right, let's do another one. We have nitrogen is 5, each hydrogen is 1, so that's going to give us 8 valence electrons. Always put the least electronegative one on the inside except for hydrogen. So hydrogen will go on the outside, and then the least electronegative element that's not hydrogen will go on the inside. We need 6 electrons to bond to the hydrogens, and then we have 2 left, and the only thing we can give it to is nitrogen because the hydrogens can only have 2. All right, the next one, carbon has 4 valence electrons, each hydrogen has 1, so that gives us 8. So this one should work out pretty well. We're going to donate 1 to each hydrogen. And then carbon has all 8 because it's sharing 2 hydrogens, 2 electrons per hydrogen, gives it 8. All right, they're going to get just a little more complicated, so stay with me. This next one, nitrogen has 5 valence electrons and oxygen has 6. So that's going to give us 11, but then we're going to take 1 away, and so we have 10. And the reason we're taking 1 away is because it's a polyatomic ion, and so it has that positive charge, so we need to take 1 away from the total that we have. So we have a nitrogen and an oxygen, and I can already tell that we're going to need multiple bonds because I remember from the nitrogen one that we did, the N2. So let's go ahead and put a double and see how that does. 2, 4, 6, 8. Whoops, that one has 8. 10, and we're almost there. We're still short some electrons. So let's take off some more. And we'll add another bond. And now we have 2, 4, 6, 8, 10 valence electrons, and everybody has 8. All right, this next one, CO2, this one is going to have 2 additional electrons. So we're going to put carbon in the middle. Always put carbon in the middle if you have a choice. So C goes in the middle. H goes on the outside. And then if you have a choice, the least electronegative one goes in the middle if you don't have carbon. All right, so C in the middle, we've got 3 oxygens. And let's add up our valence electrons. We have 4 for carbon, 6 for each oxygen, so that's 18, plus we're going to do 2 more for that negative charge, should give us 24. 1, 2, 3 bonds, that gives us 2, 4, 6. Let's just go ahead and start filling them up. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So 8, 10, 12, 14, 16, 18, 20, 22, 24. Yep, so I've used up all 24, and the problem is that last oxygen over on the left is still not stable. It has 4 lone pair electrons and then 2 that it's sharing, so that's 6, but that's not okay. So what we need to do is to take these electrons off the carbon and make it share with that oxygen. So again, when you're short electrons, that's the rule up here, not enough electrons, you need to make a double or triple bond. And now even carbon is stable because it's sharing 8 total electrons. All right, just a couple more. Phosphorus has 5 valence electrons. Each carbon has 7. 7 times 5 is 35. That gives us a total of 40. So the least electronegative one here is P. Hopefully you know the electronegativity trend increases up and to the right. So the closer to fluorine it is, the more electronegative it is. And the rule down here says that the least electronegative one's going to go in the middle. Usually the one that's by itself will go in the middle too. Now what you're going to notice first off is that P automatically is going to have too many valence electrons because it has 10, it's sharing 10 total electrons with chlorine, and the rule we talked about was 8. And you're going to learn in this chapter that there are exceptions to the rule. So we already know that there's some elements that don't need 8, like hydrogen is 2, boron is 6, beryllium is 4, but you're also going to see that some atoms can accept more than 8. And they can only do that if they're in the 3rd row or beyond. So phosphorus, notice, is in the 3rd row, and that's because what they have is an empty d orbital. D starts in the 3rd energy level, so 3d is the lowest d that you can have. So if you're in the 3p, that means they have that 3d available that they can add extra electrons. And it's a really common AP exam question to say, why can P do that, but nitrogen cannot? And the reason is because if you look at nitrogen, it's in the 2nd row, and so it's in the 2p. The valence electrons are in the 2p, and there is no such thing as a 2d. The first time that d shows up is in the 3rd energy level. And so nitrogen cannot because it doesn't have that empty d orbital that it can fill up. So nitrogen can only have 8 valence electrons as a maximum, but P can have more. So P is okay, it's got more than it needs. Let's see if we have enough electrons to go around on the chlorines. So we have 40 total, we've used up 10. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, and 40. So that works out perfectly. We don't need any extra electrons. We don't need any double or triple bonds. All right, 2 more. The next one is radon, and then we have 2 chlorines. So first, let's add up our valence electrons. Radon actually has 8. It's a noble gas, and so radon had 8, and then each chlorine had 7. So 7 times 2 is 14, plus 8 more gives us 22. Let's start this one over. So then we have radon in the middle. We're going to bond it to each chlorine. And let's go ahead and put our valence electrons around. So we have, there's 8 for radon, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 2, 4, 6, 8, 10, 12, 14, 18, 20. Yep. So we've used up 20 electrons, but we still have 2 more because we started with 22. So this is the last rule. We talked about if you're short electrons and you don't have enough in your pool of electrons, that's when you make double or triple bonds. If you have extra electrons, you're going to put them on the central atom. Extra electrons, put them on the central atom. So in this case, we're going to give 2 more to radon. So radon actually has 3 clouds of valence electrons and then plus these 2 atoms. And we're going to talk about in the next video, I'm going to talk about how to figure out the shapes for these big molecules that you haven't done from last year. All right, last one. Let's do it over here. All right, iodine and chlorine are both halogens, so they each have 7, and we have 5 atoms. So 7 times 5 is 35, plus we have 1 extra electron from that charge, makes it 36. So we're going to put I in the middle. It is less electronegative than chlorine. Again, the closer it is to fluorine, the more electronegative it's going to be. Oh, I think I said chlorine. It should be fluorine. 2, 4, 6, 8. That gets us to 8. So let's just go ahead and start putting electrons around. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So we've used up 32 electrons and everybody's stable. Everybody has 8, but we had 36 originally. So again, the rule over here, extra electrons, you're going to stick on the central atom. So we have 4 extra electrons, so we're going to put those on iodine. So iodine has 4 atoms that it's bonded to plus 2 clouds. And again, I'll show you how to figure out the molecules for these big, or the shapes for these big molecules in our next video. All right, that's it for this one. And if you take a look at the next video, I'll show you how to determine these shapes.